The next section, we're going to be talking about the economic service life. In an economic study, this is a replacement study, the alternatives and value should be the number of years at which the lowest annual worth of costs occurs, and we call this the economic service life. Okay, so that would be the year at which you have the least cost or the smallest annual worth. Okay, so you guys remember the formula for the annual worth, which is composed of two things: the capital recovery, which includes the P and the S, and then the annual worth of the annual operating cost, okay, which is your A basically. This is what it would look like in a graph. So you have the capital recovery is decreasing as the years go by, but the annual worth of the cost, the annual operating costs, increase. So if you put them together, you're going to get this the pink line that says the total annual worth of costs, and it's going to be a concave curve. Okay, the lowest point in that curve, that is going to be your ESL, your economic service life in terms of years. Okay, so this is the formula. Now there's a slight variation here. You see that CR, the capital recovery, it has a subscript K. Okay, the P, it's the same, the present, okay, or the initial investment, that one doesn't change. And the S, it also has a subscript K. And notice that for the years, you don't have N, you have K's instead. Okay, that is because you're going to be performing it. Your N is going to be your ESL. So you have to perform this for each and every year. And the one with the lowest cost, that's going to be your N. Okay, but we're going to go over that right now. I just want to point out something on the second formula. The annual worth of AOC. Okay, let me just show you this one right here. Okay, it has also the subscript K, and then you have AOC1, AOC2, etc. This formula, it's whenever you don't have uniform series, and we're going to be covering that in example 9.3. But for now, we're going to be focusing on this part right here, whenever you have uniform series. So the only thing that you need to add is the AOC in here. Okay, so let's go over example 9.2. Okay, so a device that monitors rotational vibration changes in turbines may be purchased for use in Southern California wind farms. The first cost is $40,000 with a constant AOC of $15,000 over a maximum service period of 6 years. Use the decreasing future market values and I equals to 20% per year to find the best end value for an economic evaluation. Okay, and then you are given the years of service and the estimated market value. Okay, so what does this mean? Okay, so this estimated market value, okay, so this is going to be your S subscript K. Here you have S1, S2, S3, S4, S5, and S6. Okay, they're giving you the first cost over here, which is going to be your P, so I'm going to write it over here in the bottom. So P is going to be equal to negative 40,000. Then it says that AOC is going to be $15,000 per year. So I'm going to put it here. AOC is going to be minus $15,000, but it says a constant AOC. Okay, so I'm just going to write here that it's constant meaning that it's uniform. Okay, so the only thing that you have to do is to add it. Well, in this case, it's a negative number, so you're going to subtract it from your formula. We have K, so the K is going to go from years 1, 2, 3, all the way up to year 6, because it's telling you that it's a maximum service period of 6 years. The interest is given, so it's an interest of 20% per year. Okay. And we are trying to find N. It's an unknown, but it's going to be our ESL. Okay. And I'm just going to put here the formula so that you guys don't forget. So the total annual worth is going to be the capital recovery plus the annual operating cost, which is going to be equal to minus P, and this formula is from chapter 5. Find A given P, I, K, notice that we don't use N, we use K, plus the individual salvage values each year. This is going to be converted to A, find A given F, add an interest, K, and since the annual operating cost is uniform, you just subtract the annual operating cost. Okay, you're going to perform this for each individual year, and then the ESL is going to be the lowest, okay, or the numerically largest number. Okay, so let's go over the first one. Let's do this for K equals 1. Okay, so I'm going to put K equals 1. Okay, so for K equals 1, I put that it's a total, okay, annual worth for year 1. Okay, the P is constant, so the P doesn't change. P is minus 40K. So it's going to be minus 40,000. Find A given P. The interest is given 20% per year. 20%. Okay, K is 1. Okay, plus S subscript 1. S subscript 1 is 32,000. So it's this one right here. Okay, so I'm going to put 32,000. Find A given F at 20% 1 minus the annual operating cost, which is given, and it's minus 15,000. Minus 15,000. Okay, you plug in the factors and you should be getting minus 31,000. Okay, so that is the first one. You need to do the same thing, but now for K2. Okay, so this is when K equals 2. When K equals 2, it's going to be the total annual worth subscript 2. P is the same. So it's minus 40,000. Find A given P 20% 2 plus what is S of K? S of K is going to be, we already used this one, so now we're going to use 30,000. Okay, notice that the market value is decreasing until it reaches 0 in year 6. Okay, so now we're going to use the 30,000. Now it's going to be plus 30,000. Find A given F 20% 2. Then the AOC is uniform, so I just subtract it here. And you should get minus 27,546. And you continue doing the same thing up to k equals 6. So now I have k equal to 3. Okay, and you will be performing the total annual worth of year 3. The P is the same, so it would be, I'm not gonna write the whole thing, but it would be minus 40k. So all of your k's would be 3. But for S3, you would use 24,000. Okay, so in this one, you would get minus 27,395. You would do the same thing for k equal to 4. And for k equal to 4, the total annual worth for 4 is going to be minus 26,726. Then I need to do this for k equals to 5. Okay, for k equals to 5, the total annual worth would be minus 26,897. And last but not least, k equals to 6. The total annual worth would be minus 27,028. Okay, so you would use all of these S4 for K4, S5 for K5, and in year 6, well, you use 0 for your S, meaning that the last part you put a 0. Okay, then you have all of your results. You have minus 31,000, minus 27,546, all of these. You're going to pick the numerically largest one. Okay, so here the numerically largest one occurs in which K or which year? It occurs right here. Okay, remember it's a concave curve. So it starts decreasing, but then after this point right here, it starts increasing again. So the lowest point of them all, this one right here, is going to be your ESL, meaning that the N for this problem is going to be 4.